This video was meant to show an important working principle of a rotor balancing technology known as Rotor-Mate. And by means of this simple little plywood and plastic model, the plastic indicates or is to represent a rotor, a centrifuge rotor. This shaft is the drive shaft. It happens to be a flexible drive shaft. And you can see this rotor, if it's on its geometric center, which is held right now by its held on center, it would spin here quite nicely and smoothly. However, if you take this same rotor and apply an eccentric load to it by means of, in this case, a washer, it would still rotate, but would do so with considerable vibration. And the Rotor-Mate technology allows the rotor to move with respect to the eccentric mass. It allows it to shift from the center of geometry to a new center of mass. And we'll demonstrate that by simply taking our little alignment screw and moving the rotor over to a new center of mass. And what's happening is the rotor will automatically shift over in proportion to the eccentric mass. It's something like a heavy kid and a light kid on a seesaw. And then it will begin to rotate about that new center of mass rather than the center of geometry. And you see it looks a little strange in this exaggerated condition. But in this condition, it'll actually operate totally smooth. Now, one important characteristic of this, which has been asked of people reviewing the technology, is whether or not the flexible coupling, as it rotates around the new center of mass, does the flexible coupling have to shift with each cycle or each rotation? And if you take a look at this little blue line on the upper section of the flexible coupling, you'll see that it, indeed, once the center of mass is established, it just stays on the outside, in this case, of the new location, and the coupling does not shift its angle in any way, and it just continues to rotate. It does work back and forth while it's going through or finding a center of mass, but once the center of mass is located, it no longer moves, and therefore there's no fatigue problems created by the flexible coupling as it's having to shift back and forth.